to solve problem. So here we are told that what? Cosine x is minus 2 over 3 and x is greater than 0. So here we know which quadrant we are talking about, yeah? We can know the quadrant because here we know that cosine is negative. So cosine can be negative only in the second or in the third quadrant, right? And here you can see that sine can be positive only in which quadrant? In the first or in the second quadrant. So definitely it means we have to take the second quadrant because that is what is common, right? So this can only happen in the second quadrant. So we come to the second quadrant and we draw our triangle, right angle triangle. So cosine is adjacent. So means this is minus 2 over hypotenuse, which is 3, right? And clearly you can get the opposites. What will be the opposites? It will just be what? 9 minus 4, the root. So it's going to be root of 5. Right. Okay, then now let's find the parameters here. What are we interested in? We're interested in sine 2x. And based off the formula, sine 2x is nothing but what? 2 sine x cosine x, right? And now this means that what? 2 sine x. What is sine x? Sine x is already known. We can find sine x from here, sorry. Sine x is what? Is opposite, which is root 5 over what? Over 3. Then multiply by cosine x. Cosine x is minus 2 over 3. And if you put all of this together, we should have minus 4 root 5 all over 9. Okay, now cosine 2x, we can use any of the formulas. We have 3 formulas, so you can use any one. We can use the third one, which is what? Which is 2 cosine squared x minus 1. And this is just going to be 2. What is cosine? Cosine is already minus 2, so we have minus 2 over 3 squared, then minus 1. And this is just going to be 2 multiplied by 4 divided by 3. This one, we can write it as 3 over 3, right? And this is nothing but what? 2 times 4 is what? Is 8. So we have 8 minus 3 over 3, which is simply 5 over 3. Now, another way we can solve it is that we can use, this is alternative. We can use what? Cosine 2x, which is nothing but cos squared x minus sine squared x. And this is what? What is cos squared? Cos is already known as minus 2 over 3 whole squared minus sine x is what? We know what is sine x. We can easily get sine x from here, which is root 5, right? Opposite over hypotenuse, root 3 whole squared. Okay, so here I think there is something wrong here. That is very good. We can see here. Here it's supposed to be, this is not true, because if you square this, it's going to give us 4 over 9 minus 1. So this is actually going to be 8 over 9 minus what? 9 over 9, which is going to be minus 1 over 9. Yeah, so see, this is coming from, because we try to use a different formula to check it. So here, what is this? This is now 4 over what? 9 minus what? 5 over 9. And this is also clearly minus 1 over 9, because this is 4 minus 5 over 9, and this is minus 1 over 9. So we have three formulas. You can use the other one. Remember, what is the other one? The other one is that cosine 2x is 1 minus 2 sine squared. So let's go now for tan. All right. So for tan, this is going to be what? This is tan 2 tan x over what? 1 minus tan squared x. So now we have to go and get what is tan x. Remember, we have a diagram. All right, so what we're saying is that we need to get the diagram so that we can know what is tan. And if you look at the diagram here, this is the diagram we're using. So we're in the third quadrant. So tan is expected to be positive. Tan x is going to be what? It's going to be opposites in the second quadrant. So tan is going to be negative, actually. So we have opposites, which is √5 over adjacent, which is minus 2. So tan x is going to be √5. So this will be 2. And this is minus √5 over 2 divided by 1 minus the same thing, √5 over 2 with a minus, but with a square. So now we just need to what? We just need to simplify. So to simplify this, this is going to be minus √5, just minus √5, because the 2 will cancel the 2, and here will be 1 minus. If you square this, you're going to get 5 over 4, right? 5 over 4, that is what you get. All right, so this is nothing but minus √5 over what? Minus 1 over 4, right? That's okay. And then this minus can go with this minus. So this will be just what's 4√5. So this is tan 2x. All right, now example 2. Look at example 2. We're given that the cosine of 2 alpha, it's equals to what? Minus 12 over 13. Minus 12 over 13, right? So what does that mean? It means we need to find cosec alpha. But if you look at these quadrants, how can you find cosec alpha? Let's think of getting sine alpha first. But we know that sine alpha, because we have these formulas. So let's go from this formula. We know that if you have cosine 2 alpha is what? Is 1 minus 2 sine squared alpha, right? So it means that sine squared alpha is going to be what? Is going to be 1 minus cosine 2 alpha, right? So from here we can get sine alpha. Sine alpha is just going to be plus minus 1 minus cosine 2 alpha divided by what? Divided by 2. This is one formula we can use. Yes. But if you look at alpha, we are told that alpha is in which quadrant? This is our alpha, and alpha is in the fourth quadrant. So since this is quadrant 4, it means that what? We're going to use the negative because sine is negative in the fourth quadrant. So this is all we need to use. So we can now substitute. So sine alpha is going to be minus 1 minus, we already have cosine 2 alpha. What is cosine 2 alpha is given? Is minus 12 over 13. Everything divided by 2. So this is going to be minus, this is going to be now 1 plus 12 over 13 divided by 2. Don't forget that the 2 is still under the root, right? The 2 is also under the root, so we need to keep it there. Therefore, sine alpha is minus, this will give us 13 plus 12 divided by 13 over 2, which is just, this is now 25 over 13 divided by 2, right? Okay, we're still going. Now, this is just going to be minus root of what? This, we can write it as 25 over 26. And now this, we can take the roots, which will just be 5 over root of 26. Because root of 25 is 5, right? And now this is what? This is our sine alpha. So therefore, cosec alpha is just going to be the reciprocal, which is minus root 26 over 5. Okay, just a simple explanation here. Here, why did we use minus? We use minus because of what? Because of the quadrant. We use minus because of the quadrant, because we are in quadrant 4. So if we are in quadrant 4, sine is negative in quadrant 4, because here we change everything. This is square here. So if you take the root of both sides, we're supposed to have plus minus. But we choose minus because of the quadrant 4. And in here, we already have cosine 2 alpha, just substitute directly. All right, the next example is this one. Example number 3. You look at example 3, we have simplified this expression. So which expression is this? You can see that this, you can easily factor out minus so that it becomes cosine. So that it becomes cosine squared 5x minus sine squared 5x, right? And now what is this one? This is minus of what? If you remember, one of the formulas we saw is that if you have cosine 2x, it's nothing but cosine squared x minus sine squared x. So that is why we call it a double angle, because you see here, we have x, here we have x, but here became what? The double of it, which is 2x, right? So now what we are going to see is simply that what? Since we have this one here, this is 5x, and this is 5x, we need the double of it, right? So it means we have this side. So this now we can easily write this as what? Cosine. The double of it will be 2 times what? 5x. So this is just minus cosine 10x. And we're done. Okay, so B, let's look at B now. B is a sine 75 cosine 75. So what is this? This also, it's simply follows from where? We saw that the double angle of 2 sine x, sine 2x is what? Is 2 sine x cosine x, right? So now let's put x to be 75. So it means you will have 2 sine 75 cosine 75. So what should we write on the left-hand side? Here is going to be 2 sine 2 times what? What is x? X is what? 75. So this is going to be sine 150 degree is equals to what? 2 sine 75 cosine 75. So all you need to do is to divide both sides by 2. So if you divide both sides by 2, you will have this one, right? So we'll cancel this. So it means that you have sine 150 degree divided by 2 is the same thing as what? Sine 75 degree cosine 75 degree. So you agree now that this, it means that this guy, sine 75 cosine 75, this is degree, not 50. Huh? Should be small 0. So this is just going to be sine 150 divided by 2. Right. So, and which is the same thing as a half. Sine 150 is in which quadrant? Second quadrant. So in second quadrant, sine is positive. So we just have sine 180 minus 150. And this is just going to be half. Then what? Sine of 30. And what is sine of 30 is 1 over 2. So the answer is just 1 over 4. All right. Then C. C is similar to look at this one. So we always have to look at what we have and how we can manipulate it to something that we know. So forget about the numerator now. Let's think about the denominator. This is what you have. Squared 15, right? But this is nothing but what? This is nothing but cosine of what? Just cosine of 2 times 15, right? Yeah. Because what do we know? This is what we know. We know that what? Cosine 2 theta, or yeah, let me say 2 theta is what? Is 1 minus 2 sine squared theta. This is true. Whether theta or alpha or x is the same. So what we have is this side. This is 1 minus 2 sine squared 15 degree, which is what we have. So it means this area here, the left-hand side will be cosine 2 times theta. Theta is still 15. So it means you will have cosine of 30 degree equals to 1 minus 2 sine squared 15 degrees. Right. So what can we say from here? What we can say, it means that this is simply equals to 1 over the denominator. Now we can just write it as cosine of what? 30 degrees, which is equals to 1 over, what is cosine of 30 degree? Cosine of 30 degree is root 3 over what? Root 3 over 2, right? So everything here is just going to be 2 over 3, which we can rationalize so that it becomes 2 root 3 over 3. All right. Now, number 4. This is, it says that if you have this equals to n over this. So here, why is this here? Okay, let's see. Now, this is sine cube plus what? Cosine cube. We're going to use expansion. Remember, we know that if you have a plus b, all to power 3. This is nothing but what? A plus B, A squared minus what? AB plus B squared, right? So using A to be sine beta and B to be cosine beta, we can write this. Okay, let's just write this. Plus cosine cube beta over sine beta plus cosine beta, right? This we can write as sine beta plus what? Cosine beta multiplied by what? Sine squared beta minus sine beta cosine what? Beta plus cos squared beta, correct? Now we divide by what? Sine beta plus cosine of beta. And you can see that this and this, they are the same, right? They will cancel this one. So it means that we will just have what here? We will have what left? We will have sine squared beta minus sine beta cosine beta plus this one, yes? But we know that these two should give us what? 1. So this one and this one give us 1. So this will become just 1. Okay, let me rewrite it to just... let's put this together. So you have sine squared beta plus cos squared beta minus sine beta cosine beta, right? And this is going to be what? 1 minus sine beta cosine beta. But if you look at what we have, is it close? Is it close to what we have? Look at what we have here. This is just only sine, MV. But here you have sine and you have cosine. So you need to rewrite this again. But what do we know? Because we don't need this cosine here. We know that what? We know from this formula that since I have sine, if I have sine 2 theta or 2x, I know it is 2 sine x. No, let's use beta now since we have dealing with beta. Sine 2 beta is going to be sine beta cosine beta, right? So look at this. So I have this side, which is sine beta cosine beta. So we can divide both sides by 2. So divide by 2. So it means sine 2 beta divided by 2 is the same thing as what? Is the same thing as sine beta cosine beta. Therefore, it means here, in the place of sine beta cosine beta, which is this, I can replace by what? By sine 2 beta over 2. So which I can write as 1 minus half sine 2 beta. So this is the final answer. This one is the final answer. So if you compare this now and what we have, you will see that what is n? N is going to be minus half. And m is what? Is 2. So compare this one here and this one, the final answer. So n times n is going to be what? Minus 1. And that is why we have this. Okay, so just one more and we're done. Now, example 5. So for example 5, you have 5 sine squared, this, equals to this. So we want to find n plus m. So let's start with what we have. We have 5 sine squared, 10 alpha, minus 5 cosine squared, 10 alpha. This we can also rearrange. We can take minus out, or we can even take minus 5 out. If you take minus 5 out, what do we have? we'll have cosine squared 10 alpha minus sine squared 10 alpha, right? So this looks nice now. This we can use the double angle formula for cosine. So since this is 10 alpha, it means we are going to have what? We are going to have 20 alpha, right? It's going to be double of it. So this is going to be minus 5. Then this is supposed to be cosine 2 times what? 2 times 10, right? Then alpha. So this is going to be minus 5 cosine 20 alpha. So if you compare this and this, what is n? N is minus 5 and m is what? 20. So n plus m is the same thing as minus 5 plus 20, which is equals to 15. So that is the end of this video. Thank you for watching. If you are yet to subscribe, kindly do that. And if you like it, also share with your friends. And watch out for another part of this section.